We will use a wave motion demonstration to explore wave properties of speed, frequency, and wavelength. My name is Ms. Pounds. I will describe the motion. Then Mr. Nix is working on the left side of the demonstration, and Ms. Kelly is working on the right. On the right, Ms. Kelly will use her thumb wrapped with fluorescent tape as the oscillating source of the wave that will move the yellow spot medium. This wave pulse is a single oscillation moving at constant speed through the yellow dot medium. When the pulse reaches the other end of the medium, it reverses direction, reflection. Now a continuous wave, consisting of a series of crests and troughs, moves through the medium at a constant speed. But notice the yellow dot medium itself isn't going anywhere. Now on the left side, Mr. Nix is connecting a mechanical oscillator to the yellow dot medium. This oscillating source will create a wave moving in opposite direction. We can call this the high frequency oscillation, and you can see for yourself how often it is vibrating. If anyone is counting, it is vibrating 6 times every 4 seconds. The frequency of the wave produced by the oscillation is the same as the oscillation's frequency. The distance between two wave crests corresponds to wavelength. Alternatively, wavelength is also the distance between two troughs. On the left side, Ms. Kelly has positioned a meter stick with evenly spaced tape marks under the wave. For this high frequency oscillation, you can see adjacent crests pop up at each tape mark. The adjacent troughs pop up at those tape marks, so the distance between tape marks corresponds to wavelength. If someone has really good vision, they could read the meter stick and see the distance is 35 centimeters. This is the low frequency oscillation, and you can see for yourself that it is vibrating less frequently than the high frequency oscillation. If anyone is counting, it is vibrating 3 times every 4 seconds, half the frequency of the previous oscillation. For this low frequency oscillation, you can see adjacent crests pop up at the end tape marks. When this happens, there is a trough at the middle tape mark. Similarly, when adjacent troughs pop up at the end tape marks, there is a crest at the middle tape mark. So the distance between the two end tape marks corresponds to wavelength. With really good vision, you'd see this distance is 70 centimeters, twice the wavelength of the wave produced by the high frequency oscillation. So we have demonstrated waves created by oscillations. The high frequency oscillation created a wave with a short wavelength. Then the low frequency oscillation created a wave with a longer wavelength. In fact, the second oscillation had half the frequency of the first and created a wave with twice the wavelength of the first. This concludes our demonstration.